Okay, so now we're going to talk about when you're completing the square. What do you do when your a term is greater than 1? So we were just recently completing the square on quadratics that were perfect square trinomials that had a as a coefficient of 1. And so now a is not 1, it's 5. And so how do you handle this? You're going to rewrite all the terms so that x is on the left and all the constants are on the right, and you're going to leave your space. That is no different than what you were doing before. So that's going to say 5x squared, and now it's going to say minus 6x because you've moved 6 to the other side. There's your box, equals 8, and then there's your box. Okay? So that's no different. But before you start figuring out how to make that a complete or perfect square, what you need to do is divide the entire equation by the lead coefficient. So you have to create your lead coefficient as a 1. So it's going to say x squared minus 6 over 5x plus, there's your box, equals 8 over 5 plus, and there's your box, so that whatever you add to one side of the equation, you also add to the other. Now, as you can imagine, when there's a fraction in the middle, things can get a little crazy. So first, to complete the square, remember we need to find b over 2 squared and then complete the square. So b over 2, b over 2 squared. So I would have to say 6 over 5 over 2 squared. And I know many of you really dislike dealing with fractions, so I want you to think about what b over 2 means. b over 2 means I'm taking b and I'm dividing it by 2. It means I'm taking the middle term and I'm taking half of it. So you could think about this as b times 1/2. b over 1 times 1/2, or just b times 1/2. Okay? And if I think about it that way, b, 6 over 5 times 1/2 squared, that looks a little more familiar to us, and we're able to deal with that a little better. So half of b, multiply it by a half, multiply across the top, 6, multiply across the bottom, 10, and now I need to square that. So it's the same thing as 6 squared over 10 squared. 6 times 6 is 36. 10 times 10 is 100. So there is half of b squared. So I'm going to add 36 over 100 to both sides of my equation. And I'm just going to simplify at this point. So I'm just going to continue to write and continue to simplify. So I'm going to rewrite my perfect square trinomial. Okay, so x times x gives me x squared. And then what goes in this last term? Well, remember that that last term, what goes here, is always half of the middle term. So half of the middle term, if you look at what we were working on a minute ago right here, that is half of 6 over 5. So 6/10 goes here. You will also notice that it is the square root of the 36 and the square root of the 10. Those are the numbers that go there. Equals, and then what you have to do here is we're adding 8/5 plus 36 over 100. So I'm going to come over here and simplify that for you. 8 over 5 plus 36 over 100. Cannot add them unless they have common denominators. So I have to change my 5 into a 100, and I do that by multiplying by 20. So if you multiply the numerator by 20 as well, you get 160 over 100 plus 36 over 100, which gives us a total of 196 over 100. And that's what we put here. Okay, these ones that we have to break down that have a coefficient greater than 1 are pretty sloppy, so you have to be very careful about what you're doing. Now I'm going to square root both sides. So when I square root the left and I square root the right, I get x minus 6 over 10 equals square root of 196, lo and behold, is a whole number, 14. And square root of 100 is 10. So I get rid of all of my roots and I have whole numbers. Now I just need to get everything over on the right-hand side of the equation. So add 6 over 10 to both of these. So when you write this, x equals, remember you put that first number and then you do your plus or minus. So this is actually telling me two answers. I have 6 plus 14 over 10 and 6 minus 14 over 10. 6 plus 14 is 20. 20 divided by 10 is 2. So that's one root. My parabola crosses at 2. And 6 minus 14 is negative 8 over 10, and that simplifies to negative 4/5. So there are my two roots, 2 and negative 4/5. At this point, it might be smart for you to stop the video, go back to the beginning, and just re-watch that without having to write it down and just kind of absorb what was done there. Just make sure you really are paying attention to what needs to be done. All right, so let's look at this one. And I often run out of space, so you're going to have to bear with me here. So again, I have to divide everything by 2. Okay, so I'm dividing everything by 2. So I get x squared plus 1/2 x plus, there's my box, equals 6 divided by 2 is 3. But instead of 3, I want you to just leave it as 6 over 2. And you're going to see in a minute why that's important. It's very tempting to simplify that. I don't want you to leave it that way for right now. So we have to do 1/2 of b. So b is 1/2. And if I take 1/2 squared, of course, b times 1/2 squared. If I do 1/2 times 1/2, I get 1/4. And then if I square it, 1 times 1 is 1, 4 times 4 is 16. So I'm going to add 1/16 to the left and 1/16 to the right. Now it's a matter of doing some simplifying. So just like in the example up above, I had to come up with what my common denominators were here so that I could add them together to get the 196 over 100. Okay? And so I'm going to have to do the same thing in this problem. Let's break down this trinomial first, though. So x goes here, and then, of course, the square root of 1 is 1, and the square root of 16 is 4, or half of the middle term. 1/2 times 1/2 gave us 1/4. It's positive, equals. Now before I can add these two together, I need to change the first fraction into 16ths, and I did that by multiplying by 8. So I also have to multiply the numerator by 8. 6 times 8 is 48. So I have 48/16 plus 1/16, which gives me 49/16. 49 and 16 are both perfect squares. So again, this is going to work out fantastically when we square root both sides, because we're going to get x plus 1/4 equals plus or minus the square root of 49 is 7, and the square root of 16 is 4. And then the last thing that we need to do is subtract the 1/4. And again, that's going to go in the front. That's the piece that always goes in the front, whatever you're bringing over from the other side of the equation. So x is going to equal negative 1/4 plus or minus 7/4. So negative 1 plus 7 over 4 and negative 1 minus 7 over 4. Two roots. So the first one simplifies to 6 over 4, which is 3 over 2. And there's your first root. And the second one simplifies to negative 8 over 4, and negative 8 divided by 4 is negative 2. So there's your second root. Okay, again, probably should back it up to the beginning of this problem and just kind of absorb it by just watching it this time and not having to write anything down. All right, last problem. This one's going to have some nasty numbers in it. What's going to happen is we're going to end up with a negative root, and we're going to have to figure out how do you handle that negative root in your answer. So far, all our answers have simplified to whole numbers or fractions. But we know in Algebra 2 that we often get answers that have complex numbers in them. Negative roots, we have imaginary numbers, and we have to figure out what we're going to do with them. So this is a good example to have for your notes. We need to move the 3x to the left side along with the 2x squared. Okay, and I'm going to end up probably running out of space. So 2x squared minus 3x plus whatever the value is I need to add here equals negative 4 plus whatever the value is I need to add here. And of course I need to divide everything by 2 because the lead coefficient has to be a 1. So x squared minus 3 over 2x plus, there's my last term. And then again, I know it's tempting to tell me that that's equal to -2, but leave it as a fraction for now. All right, half of the middle term. I'm going to come up here where I have a little room. Half of b squared. So I need to do 1/2 of 3/2 squared. Multiply across the top, multiply across the bottom, and then square it. 3 times 3 is 9. 4 times 4 is 16. So I'm adding 9/16 to both sides of the equation. Okay, 9/16. I'm going to go ahead and simplify the trinomial on the left. X, and then square root of 9 is 3. Square root of 16 is 4. And then I have my squared item. Again, I can't add the two fractions on the right side of the equation until I have common denominators. So I'm going to change this to 16ths, which means I multiplied by 8. So -4 times 8 is -32. So -32 over 16 plus 9 over 16 gives me -23 over 16. And in the last problem, you can see that we had perfect squares there. And this time, we don't have a perfect square in that -23. So we're going to have to figure out what we're going to do with that. Square root both sides of the equation. Okay, so we get x minus 3/4 equals the square root of -23 over the square root of 16. Okay, so I'm going to make some room, get rid of some of the stuff up here, so I can add some space for you and finish out this problem. So if I bring the problem up, I have x minus 3/4 equals the square root of -23 over the square root of 16. So I know the square root of 16 is 4. I'm good there. I also know that this negative can come out as an I, but I also know that 23 doesn't break down. It has no perfect squares, so the 23 is going to have to stay under the radical by itself. So this now says plus or minus I square roots of 23. And then I'm going to get x by itself. So I'm going to add 3/4 to both sides of the equation. Okay? X equals 3/4 plus or minus I square roots of 23 over 4. You'll also notice that I ask you to leave these in fractional form because most of the time when you get to the end of the problem, your denominators have exactly the same value, which means that you can put them together over 1 instead of leaving them as two separate fractions. So your answer here, it looks like this. X equals 3 plus or minus I square roots of 23 over 4. There are actually two answers. This is how you write your answer formally, and that's the answer you would give. When we ask you what's the answer to this problem, this is what you would say, 3 plus or minus I square roots of 23 over 4. But what I need you to realize is that there are actually two roots here. 3 plus I square roots of 23 over 4 and 3 minus I square roots of 23 over 4. Oops. Okay? So there are actually two roots there. We just leave them combined, and we can't graph these because they have imaginary numbers in them, so there's not much more we can do with them. Okay? All right, so that is completing the square when the lead coefficient is greater than 1.